I welcome you all for the today's session on the loaders and the linkers. First, let us see about what exactly is the loader. So, the loader is a system program, and what is the responsibility of the loader? It is to load the object program generated by the assembler into the main memory. So, you can see this picture which depicts clearly as this is what the source program which is generated by the programmer, which is given to the assembler, and the functionality of the assembler which you have already studied in the previous concepts as which generates the object program. So the assembler has taken the input as a source program and produced the object program. Now it is the responsibility of the loader to load this object program into the main memory. Here is a question: why you want to load the object program into the main memory? Remember, any program for that matter, any program you write for the execution, this has to be loaded to the main memory, then only the program which will get executed. So that process of loading your program into the main memory, that will be taken care by the loader. So suppose this is what your source program which is given as an input to the assembler which produces the object program. So the obvious extension of the object program, it is the .obj, which is .obj, and which will be the input to the loader, and that loader which load into the main memory which is ready for the execution, which is so called your executable file, nothing else, the extension of which it is .exe. So this is the final depiction of the process of your loader that loads the object program generated by the assembler into the main memory. Why? For the execution, because until unless any program which is loaded to the main memory, it will never get executed. But if you want to load your program to the main memory, it must be in the form of a object codes, or you may also call it as a machine codes. And who will generate those machine codes are the object codes? It is done by the assembler. So assembler has generated the object codes which is in the form of object program, and once the object codes are ready, those object codes from the object program will be pushed into the main memory, and that will be the process of your loader. So based on that, here are the three basic functionalities of the loader, I can say. So which reads the object program. Who has given the object program? It is purely the assembler has given the object program. That from that object program, your loader has to read that object program as the input, and then from that object program, or at the time of object code generation or object program generation, assembler might have given some starting address for the object program. Based on that starting address, your loader has to verify in the main memory. That is what I had written here as a step 2. So your loader has to verify in the main memory. Basically, it is not the actually process of the loader that is actually given by the OS. So here internally your loader has to contact your OS. I can say in the general sense, I can tell you in the general sense that, so where exactly which part of the main memory is available free, that will be given by your OS. That will help you your loader from where it has to start loading. Suppose, so that is how what we say here. So you need to check the empty space available in the main memory. Once after it finds the empty space, then what it's supposed to do, it has to keep pushing the object codes from the object program into the main memory. That I can say that which is the actual process of storing or actual process of loading. So here I had highlighted the three major steps of your loader. One is reading your object program, checking for the space availability. Once you get the space, then you store into the main memory. So here, so what you are storing, the object codes which are generated by the assembler, those object codes which you are storing to the main memory. So this is the normal process of your loader. But here I have two questions for you. Suppose, what if the object code may not be a single file? What I mean to say. So here we said that loader will be pushing the object code from the object program into the main memory. Suppose you consider there is a there is a perspective that, however, we had studied in the previous concepts as a means of program linking, or there is a necessity of program link with respect to either you consider with respect to control sections or program blocks, where there is a necessity of combining the multiple object programs. There will be a multiple object programs, so those multiple object programs need to be combined then loaded to the main memory with respect to the control sections, as an example which you had studied in the previous concepts, as because you had studied with respect to control sections as for every control section you used to generate a separate object programs. So but while loading to the main memory, you cannot load them as a separate executable files into the main memory. Those has to be combined together and loaded to the main memory. Who will do that combining? That will never be done by the loader alone. There is a necessity of some other tool or some other logic behind that combining process. So that is what the answer for these questions. That is, what if the object code may not be a single file, if there are multiple object files, so and you need to generate the executable file based on the multiple object files or object programs, then that cannot be done by the loader alone. It cannot be done by the loader alone, so you need the linker. So here you can observe, this is what I mean to say. There are multiple source files. For those multiple source files, there are multiple object files. For multiple source files, there are multiple object files. All those multiple object files need to be linked together, or in the other way I mean to say, combined together. So all these object files are independent to each other, but you need to make it them as interlinked or dependent on each other. So that process of linking or combining, giving a logical link to each and every other object files, that will be taken care by the linker, and it will not be done by the loader. So at the time of linking, so as a part of a linker, I can tell you there are two major functionalities which will be carried out by the linker. One is combining the multiple object files belongs to the multiple source files related to the same executable file, or you can say same process. In such case, you need to combine multiple object files, that will be taken care by the linker. And the second thing is that in your source files, you might have used any number of library files. You might have used library files which are already available. You might have used them directly, but does the object code of those library files will be there in the object program in a sense? No, because your object file will have only the object codes belongs to the instructions of your source file only. But you are using the library file instructions you are using in your program, but from where can you get the object code related to those library files? In the sense, it is from the runtime library. And who will fetch? It is again the linker. So remember, your linker does not only combine the object files belongs to the multiple source files, it will also fetch the object codes related to the library files which you used in your source file or source program. So the object codes related to the library functions which you used in your source program, even that should also be fetched and linked by the linker. Then only it produces the executable program, and that will be loaded to the main memory by the loader. So here few functionalities of the linker as such. It links the multiple object modules into the single executable code. So it will link multiple object files or object programs or object modules, I can say. Next very important thing is that it will also fetch the object codes from the library. It will also fetch the object codes of the library. Object codes of what? Object codes of the library functions which you used in your source program. So those will also be fetched by the linker. So again I repeat, if you are using any library function in your source program, even the object code of that should also be fetched. But does it will be done by the assembler for generating the object program in a sense? No. Your assembler will not fetch the object code of the library function which you are using in your source program. So this object file will never have the object code belongs to the library function which you used in your source file. That will be available in the library. That will be available in the library, and that will be directly fetched by the linker. That is what this second point says. Then third point it again, which clearly says that, so if suppose if you do not include any library, that's what, there are some cases where the library do not include the complete library functions. It only give the references to such object files. It is to reduce the memory consumption and also to reduce the duplications. There will be, suppose like you are using your library function but that may not be get executed. In such case, there is no need of you to load the complete object program, or I can say object codes into that main memory. In such case, it is enough if you just provide the references to that. So all these things you will be learning further. So the next is that which is dealing with the relocation process. However, you had studied a little bit of the program relocation in the previous classes. If there is no available memory space in the main memory, however it is mentioned in the it is not available in the main memory, however it is given in the object program. So in such cases, there is a necessity of you to relocate the program. So suppose if you relocate the program, definitely the address will modify. When the address will modify, the object codes will vary. So how can you provide the logical linking between each and every that modified addresses? In the sense, again you do make use of the linker. The last one, based on the relocation which will happen, the relative addresses of each and every symbols will also vary. Whenever the relative addresses of each and every symbols will vary, definitely the object will also define. That's what object codes will also vary. Even that will be also be taken care partially by using your linkers. That again you will be studying further. So till now what I mean to say, so yes, we say that loader will be loading the object program to the main memory, but suppose there is a necessity of you to link the multiple object codes to the single executable file. That will not be done by the loader, and also it will never fetch the object codes from the library. In such cases, you need the linker for what? For combining the multiple object files of the multiple source files into the single executable file, and also it has to fetch the object codes belongs to the library functions which you used in your source file. Even that will be taken care by the linker, which will not be done by the loader. So now the complete depiction, let us change little bit as. So however, your assembler will generate the object code of your source program, and before that source object code will be loaded to the main memory. So linker will act it will perform its functionality as such. If there are multiple object code files, then combine them, and also if there is a necessity of linking from the library, which will also be taken care by the linker, which is producing the executable code. And once it produces the executable code, that will be loaded by the loader to the main memory. That is the complete process which we can say here. So we say it as loader, which brings the object program into the main memory. Very importantly, which brings into the main memory, and as soon as it brings to the main memory, so it means it is ready for the execution. So start that execution. So once after you load the object program into the main memory completely, it is ready for the execution. So you need to start the execution. That will be taken care by the loader. But what does the linker does? Linker, it is to link the separate object files if there are available, and also if there is a necessity of relocation, that will also be linked together, and the linking should be also be given with the library files. That will be taken care by the linker. So this is all about the basic introduction about the loaders and the linkers. Now let us move on to the next very important thing, is that an absolute loader. Try to remember an absolute loader. However, the name itself specifies an absolute which doesn't require any modification. It is a perfect. Absolute means it is a perfect which doesn't need any modification. So what I mean to say modification, in the sense Per suppose, here from this 3 points you may understand better. So as usual, you read the object program, check. This is a very very important second step. So if per suppose the address which is considered in the source program and the object program, if the main memory is also available free at that space itself, then your loading can takes place directly without the necessity of linking and program relocation. That is what I mean to say. Perfect loader, absolute loader, which doesn't need or which doesn't rely on this, or which doesn't need of this linking and the program relocation. In such kind of loader itself you call as an absolute loader. So what it does, it takes the object code from the object program and keep loading to the main memory. So you see here, it has to take the object code from the object program and keep loading to the main memory continuously. From where? From the starting address, however it is mentioned in your object program itself, because you doesn't need any linking and the program relocation. In such case, for the case if you don't need the program relocation and the linking, in such case only you can make use of the absolute loader. What if you want to implement linking and the program relocation, then can you make use of absolute loader? In the sense, definitely no. Absolute loader will not fit for the program relocation and the linking process. For that we have a separate kind of loader which you are going to see further in the further classes. But as of now, if the main memory is available free at the space which is assigned at the time of assembler, which doesn't need any relocation and the linking, such kind of loader, it is the absolute loader. So what it does, it takes the object code from the object program and keep loading to the main memory. Let us take an example here. This is the given, or this is the object program which is generated by the assembler. This is the object program generated by the assembler, and from this, if you see properly, this is the header record. From this header record, what you can make it out, this is the H followed by the name of the program followed by the starting address, and also very importantly length of the program. This is what I mean to say. What, based on what you decide whether it is absolute loader or whether you want to make it as absolute loader or not, in the sense. So I mean to say that you check from this object program, check the header record. From the header record, obviously you can get the starting address, and this is the starting address 1000. You check, you need to verify in the main memory whether the main memory is available free from this 1000 starting address, and how much memory space you need. It is what, 107A. If 107A bytes of memory space is available freely, or empty space, I can say, if the main memory is empty, how much empty space you want? It is 107A, so many bytes empty space. From where? From the 1000. If it is available, then you need to start loading these object codes, because I hope you know that object codes will be available in the text records only, not in the header record, not in the end record. So if the main memory is available free, how much memory space to be empty? It is these many bytes has to be empty. From where? From this starting address. If it is available empty, then you start loading these object codes from the text record in the assigned locations. Till when? Till you reach to the end record, because once you reach to the end record, that is end of the text records and end of the object codes. So you read the header record, fetch the starting address, check in the main memory whether main memory is available empty. From this address, how much space? It is these many bytes of memory space to be empty. If it is available, so then make use of the absolute loader. For what? For loading these object codes from the text records continuously based on the given addresses. Based on the given addresses, you keep loading by considering that these object codes are in the hexadecimal. Very very importantly, these object codes must be in the hexadecimal. And however, we know that every hexadecimal number requires the half byte. As every hexadecimal number requires the half byte, so and the memory addresses at the beginning itself, we have came across with that memory addresses will be completely a byte addressable. So here you cannot split any object code. So what you can do, what I mean to say, every hexadecimal number requires the half byte, so every 2 hexadecimal numbers makes one complete byte. At any point of time, memory addresses cannot be represented with respect to the half bytes. So you need to represent in the form of a full complete byte. So only we used to call it as a byte addressable. So here you keep loading the object programs, keep loading the object code from the text records continuously based on the given memory locations. Once after you load this hexadecimal object codes from the main memory, from the object program into the main memory, then once after you reach the end record, right after the loading is completed, then the execution will begin. From where the execution will begin? From the address space which is given, the address which is assigned with the end record. So the execution has to begin with the address specified in the end record only. So again, let me make it clear. So once after your complete object codes belongs to the complete program is loaded to the main memory, which means to say that it is an executable file which is ready for the execution. From where the execution has to begin? From the address which is specified with the end record. From there the execution has to begin. So now let us see how it has happened. Again, you will look here, this is the object program and this is the main memory. From this main memory, again make a clear point that so if you observe right here, this is what the memory address space is. This is the memory address spaces, and here is my memory architecture. And as I am considering here the memory architecture with respect to the SIC, so let me deal with the SIC. And if you remember, with respect to SIC, the maximum memory space we used to said as 2 power 15, because it is totally 16 bytes of memory space, 16 bytes of instructions which we had. So here memory space, it was if you keep counting from here, it is something like, it is, you observe this, it is 0 1 2 3, again 4 5 6 7, again 8 9 10 11, again 12 13 14 and 15. So it is what 15 is nothing else F. So that is why we had 2 power 15 in our memory architecture of your SIC. That's what I mean to say. So just 2 power 15, and here is we have it is 15. And again, as you started from 0, so it is totally 16. So as you started from 0, it is 0 to 15, so I mean to say it is 16. Now let's see. So it is, so per row, if you observe, how does this address is assigned? It is not random. Again, how does it is address is assigned? So here it is a 0. I will start with the zeros, and you observe again, let me count it again. I said these 2 half bytes makes one complete byte, 2 hexadecimal places makes one complete byte. So these two makes one complete byte. So it is 0, 0th byte, first byte, second byte, third byte. That's what I mean to say. 0 1 2 3, again 4 5 6 7, again 8 9, after 9 it is A, again B, again C, D, E and F. After F, what is the next address? It is the 10. You observe, this is the 10, this is the 10, again 10 11 12 13, again 14 15 16 17 18 19 1. After 19 it is 1A, 1B, 1C, 1D, 1E, 1F. After 1F, what is the next address? It will be a 20. Like that you keep counting, and here is the address which is F0FF0, and by the time it reaches here, it will become 1000, which is 1000 in the hexadecimal address. Now you see from the main object program. From the object program, we made it clear that starting address is 1000, and this is the starting address which is 1000. And we also made it clear that the main memory it is empty for how many bytes? It is for the 1078 bytes. So till 1078 bytes. So those many. So in what I mean to say, if you the starting address is 1000, then how many till when, in the sense it is till 207A, because the length should be a 107A. So from 1000 till 207A, the main memory is, we need to check it whether the main memory is empty or not, and here it is empty. Now let me load it. So from where I can load it? So from the text record. Again you refer from the text record. Here is the text record. The starting address for this text record is the 1000, and you keep loading these object codes from the 1000. So I load it. Yes, 141013. So 141033. Again 4820. So this is continuous. Obviously it is 482039. Again comes to picture 001036. So 001036. Again 281030. It is 281030. Again you got 301015. 301015. Again 482. You see this 482061. So here is the 48 and the 2061 has come here. Even if you observe carefully, what was the address of this, you can also count. So the address of this, it is, if you observe, this is what address it is: 1000, 1001, 1002, 1003, 1004, 1005, 1006, 1007, 1008, 1009. After 1009, what is the next address? Obviously it will be 1000A, 1000B, 1000C, 1000D, 1000E, 1000F. So 1000 and F, which is having the 48. 1000 and F, which is having the 48. Again this will become what? 1010, because 1000 and F has 48. Then it will become 1010, which is 1010. So this 20 will come to the 1010 position. Again 61 will become the 1011. Again 3C will go to the 1012. Again 10 is a 1013. Like that it will be continued. Till what address? Till the 1033. I can tell you it is till the 1033. How? So this is the last. So it will be keep continuing. So even if you observe in the other means, the second text record, it is starting here, and what was the starting address of the second text record? It is 101E. You make it from this. It is 1010. It is 1010, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. After 19, 1A, 1B, 1C, 1D and 1E. So what does it should have from here? This is what the object code belongs to. This 1E, from the 1E, what is starting? Which is 0C1036. So 0C, which is from 101E, 1F has 10, again 120 has 36. Again continuously. So till here. So till 1033, 1032. This is 1030, 31 and 32. So you'll be having the object code still here. So I hope you are getting this. Next is, you understand, we are end with the current text record here, wherein the next text record is starting at the address 2039. You observe this, from this 1032 till 2038. Till 2038, this is the amount of memory space which is left as empty. From the in your program also, we left it as a buffer. So many bytes which are allocated for the buffer by using the reserve byte, which is just an empty space which is allocated, that can be or that might be used further. So here, so from the address, from where 1032 till 2039. Why till 2039? Next text record, it is starting at the address 2039. Till that, this is the empty space which is allocated for the further usage. So again at 2039, what is there? It is 041033. Again you understand, it is not starting at 2030, it is starting at 2039. So for that, it is, you observe again, it is 2030, 31, 32, 33, 34, 35, 36, 37, again 38. So till this 2038, the amount of memory space will be empty, and this object code start from the 2039. This 203, after 39 it is 3A, 3B, again 3C, 3D, 3E, 3F. Next object code will be come to the 2040, which is the, so that is of these object codes as well, it will be stored continuously. Again, if you take up the next text record, which is this 2057, what is there in the 2057? It is 101036. Can you verify? So you see in this 2050, 50, 51, 52, 53, 54, 55, 56, 57. From here it is starting. What is starting? It is 101036, which is 101036. So like that you keep loading till what? Till the last object code. In the other way I mean to say, till you reach to the end record. So what we did here, try to understand what we did here. You read the header record. From as soon as you read the header record, you made sure that the main memory is available free or empty from the starting address. How many bytes you want to be empty? From these many bytes, 1078 bytes need to be empty. So it means to say that from 1000 till 2078, so till that amount of memory space to be empty. And you made sure later on what you supposed to do, keep loading the object codes from the text record into the main memory at the respective memory locations, whatever it is assigned already. So based on the assigned addresses itself, you keep loading to the main memory at the respective memory locations. So once after you are done, or once after you reach to the end record, then the execution has to begin at the address which is specified at the end record. So here also if you observe, I mean to say, once after you are done with the loading process, next process is obviously the execution. But from where the execution has to begin? Execution should not begin at the either 0 or 100 or at the 2000 or at the 5000. Obviously the execution has to begin at the 1000 itself, because this is what the object code belongs to our program, and this is where the execution has to begin, not anywhere else. So it has to begin exactly at the 1000. From where do you get that address? It is from the end record only, not from anywhere else. So the same process, I hope you understood clearly. The same process it is put in the form of algorithm. You can observe here. So what is there? You need to read the header record. From that header record itself, you will get the length. You will get the starting address and also length. You verify in the main memory. Once after you verify, what is supposed to do? You read the next text record. You read the first text record. Once after you read the first text record, and you are supposed to keep loading until what? Until you reach the end record. You keep loading. That's what I mean to say. Move the object code to the specified location. Very importantly, you will be loading to the specified location itself, not anywhere else. Here also I shown this. So suppose you take up this. Here is an object code which is 382064. So this should be loaded the 2073 itself, not anywhere else. So if you want, make it out. So it is 2070 71 72 73. This is the 73 382064 like that. So you need to move the object code to the specified memory location in the memory. Once after you are done with the current text record, then again read the next next text record. Until when? Until you reach the end record. Once after you have reached the end record, then you need to jump to the address specified with the end record. This is what I say. Once after you are done with the execution of everything, once after you are done with the loading of everything, then you need to jump to the address which is specified with the end record. Why? For begin the execution. So that is what, once after you are done with loading everything, then you will be jumping to the address specified with the end record. Why? For starting the execution process. So this is what the absolute loader. This is the functionality of an absolute loader, and this algorithm belongs to that absolute loader. But there are the drawbacks of this. There are the two main drawback of this. This is the two main drawback. What is the two main drawbacks? I can say it is, what if the memory space is not available at the free space specified in the main memory? What I mean to say. So here in my example, it is said as the starting address should be 1000. So in my memory, the main memory was empty from the 1000. What if for the purpose, like if the main memory is not available from the 1000, it may be available from the 2000 or it may be available at the 5000. But if it is not available from the 2000, can you make use of absolute loader? No, you can't make use of the absolute loader. What about the second? What if the main memory is not available free together? What I mean to say, per suppose, yes, the main memory is available from the 1000, but the main memory is not available main memory is not available empty till 2078. But what we need this, because of our program length, it is 107A, we want to be from 1000 till 207A, because our program length is 107A. So from 1000 till 207A we want this to be empty space. What if the main memory is available free from the 1000, but it is not available till 207A? Something might be already loaded at somewhere from 2000. So that is what, if the main memory is not available together in a single memory space. So in these two cases, can you make use of an absolute loader? No, you can't make use of absolute loader for these two cases. So what do we use for this? What is the kind of loader we do make use to resolve these two issues? That is what the next topic which we are going to see further. Thank you.